Today, I want to talk a little bit about how we can make use of the science of learning to effectively manage our classrooms and to teach our students to the best of our ability. Ultimately, what faculty tend to do is they tend to teach students the way that they were taught. And it turns out that for many years, faculty using this strategy taught students in ways that worked for faculty members who would eventually go on to get PhDs, but didn't work for all of the students out there who were your constituents. The goal of the science of learning is to try to help faculty understand how students learn, and then to translate that learning, how we know how students learn, into the classroom. So what we're going to talk about today is how to take this concept of the science of learning and maximize the usage of the science of learning in a way that's going to best help our students learn effectively. Now, we're going to start with a little bit of an understanding of memory. Now, this is a model of memory. And if you look at this, it's an integrated model of knowledge that allows us to understand that things that are related to each other are connected, and there are things in each of these nodes that are connected to multiple things. This notion of interconnectivity in memory has to do with a number of different factors. One is there's this general knowledge that we all acquire just by being alive and by interacting with things in our culture. But there's also specific knowledge that we acquire as we're trying to learn. One of the keys to learning effectively and remembering effectively is encoding something new into a memory structure that is integrated, that is highly interconnected, and so that you can, when you learn something new, you relate it to something you already know. That way, when you're trying to remember something later on, you have multiple pathways to get back to it. So for example, if you look at this model right here, this word has all of these different connections. So there's multiple ways to get back to that concept. If you learn a concept and you learn it in isolation, you don't have the ability to get back to it easily. When we're teaching, if we understand that if you encode information into an integrated network of knowledge you already know, it's much easier for students to be able to remember that later on. In addition, it's also easy for students to be able to make additional connections to that information as they learn new things throughout the course. Now, how do you take this knowledge and make it effective in your class? Well, one of the things that we need to know, or we need to work on in our class, is we need to help students encode information. Now, this notion of encoding is the idea of taking information from the course and somehow integrating it into the knowledge base that we've already developed. Now, this encoding needs to be elaborative. So there are a number of ways that we can encode in an elaborative fashion. First, we can use imagery. We can encourage students to use some kind of visual imagery that'll help them effectively encode the information. Another way is to help students connect with previous knowledge by overtly talking about that, by telling students, make sure you work to connect this up to what we've learned before. Now, in terms of science of learning principles, if you know that effective encoding is going to lead to better memory, how can you maximize that in the classroom? Well, you can use a number of strategies, one of which is called test-enhanced memory. And this is the idea that by using short, simple quizzes to encourage and require students to continuously retrieve information from memory, they're more likely going to be able to recall it, not just in the short term on the next exam, but they're also going to be able to recall it long term. If you continuously ask them to retrieve it from memory, what ends up happening is they end up really interconnecting that information into memory in a way that is going to be easily retrievable. It's going to create multiple roots. The way we saw back here on this slide, it's going to create multiple roots. A third thing we can do is we can use something called the spacing effect. Now, the spacing effect is the idea that teaching students to study, take a break, study again, take a break, is going to maximize their ability to remember things, because as they take that break and they space out their studying, students are increasing the number of times they have to encode, and they can encode elaboratively. It causes them to have to retrieve the information, they have to keep recalling it to be able to study again, and it's over time, so it helps students really build those memory structures up well. Now, there are a number of other strategies that we'll cover in other videos, but as a start, if you want to use the science of learning to really effectively help your students learn in the classroom, some of these principles are easily identifiable and adaptable within your class, within the structure of your assignments that you already have, that will really benefit your students and lead to better learning. Thanks.